Hello everyone, I'm Sejal Karna and I'm a student of civil engineering. Today, I'm here to tell you all something about structural health monitoring, simply known as SHM. So let's understand the basic concept of SHM. Any structure, either it's a road or tunnel or bridge or building. In building also, either it's commercial building or residential building. Every single structure needs to be monitored time to time. If we won't monitor the structure time to time, then its lifetime will be very less and it will get completely damaged before its expected time. Monitoring and maintaining any structure costs much less than rebuilding the same structure. So let's see what is SHM, its history, why do we need SHM and what all does the SHM include.
Structural health monitoring. So, what is structural health monitoring? Structural health monitoring, simply known as SHM, refers to the process of implementing a damage detection and characterization strategy for engineering structures such as bridges and buildings. SHM is necessary for the present time as rebuilding any structure is costly and could be dangerous to living lives. As we can see, the below picture is of a city where there are bridges, building everything, and a random person is monitoring them. History. In early time, SHM was not so in top, but the majority of SHM research conducted over the last 30 years has attempted to identify damage in structures on a more global basis. The past 10 years have seen a rapid increase in the amount of research related to SHM. Many papers, journals, etc. were published in this topic, which helped it to gain fame. Why we need structural health monitoring. Owners and maintenance managers of capital intensive assets are looking for cost effective and reliable inspection and monitoring solutions to ensure safety and reliability of these structures. Modern design codes are now looking in a much longer service life. Municipalities, provincial and federal government are becoming interested in the concept of a smart city. Another important application of structural health monitoring is to improve reliability of existing infrastructure. So here are some pictures about structural health monitoring. So the first two pictures are of monitoring. So the first picture is showing a person is monitoring everything. The second picture is showing the sensors which are used to sense the damages from the bridge, and the third picture is of a smart city. So this is a basic simple idea of a smart city, like the Wi-Fi, the vehicles, everything is connected to each other. Structural health monitoring and civil infrastructure. Depending on importance, ownership, use, risk, and hazards, civil structures such as building, bridges, etc. have inspection, monitoring, and maintenance programs that may even be mandated by law. The effectiveness of maintenance and inspection programs is only as good as their timely ability to reveal problematic performance. Hence, the move to supplement limited and intermittent inspection procedures by continuous, online, real-time, and automated systems. Major drivers in this area have been the oil industry, operators of large dams, and highway agencies, which installations have received the greatest attention and research effort. Residential and commercial structures have received relatively less attention due to the potential obligations and consequences of owners knowing about the poor structural health. So, if we'll talk about civil infrastructure and the SHM, they both are connected to each other. Every civil structure needs to be monitored. If it isn't monitored at time, then it may get damaged very fast. So, the oil industries, the operator of large dams, highways, bridges, they are getting more attention. But the residential structures, they are getting less attention because people are not aware what is SHM. So that's why residential and commercial structures have got a little attention in comparison to those of industries and dams. So what all does this includes? SHM includes modifications to an existing structure, monitoring of structures affected by external works, monitoring during demolition, structures subject to long-term movement or degradation of materials, feedback loop to improve future design based on experience, fatigue assessment, novel system of construction, assessment of post-earthquake structural integrity, decline in construction and growth in maintenance needs, and the move towards performance-based design philosophy. So structural monitoring doesn't only include monitoring something, but it also includes modification and assessment of post-earthquake, like when earthquake came, then what happened after that, or what would happen after that, to look. This is also includes in structural health monitoring.
So this was all the basic concept of SHM. Whenever we think about SHM, the most common word which strikes our mind is damage. Damage means monitoring and monitoring means structural health monitoring. So let's see what is damage, how is it related to SHM, and what are the technologies to see the damage.
Damage. What is damage? Damage can be defined as the changes in geometric properties which favorably influence present and future condition. SHM technology includes modification of structures, observing the destruction, structure subject to long-term movement or degradation of materials, quantifying the severity of the damage, and many more. There are different aspects to monitor, such as displacement, strain, load, tilt, vibration, stress, etc. So sometimes the damage they are in the displacement or the strain or load or stress, etc. So the damage could be due to the uneven management of these things. There are four key technologies for structural testing and structural health monitoring. They are: first, multimodal sensor system; next, robust precision signal conditioning; third, distributed measurement systems; and fourth, software technologies. So let's see what these four are. First of all, multimodal sensor system. Sensor technology is one of the most active areas of structural testing and monitoring research and technological advancement. Most SHM systems today use sensors such as strain gauges, vibration or accelerometer sensors, and displacement sensors to track the stresses or movement of a structure. Additionally, the system usually includes sensors for environmental or weather monitoring. A number of emerging sensor technologies use non-destructive testing. So these two are the picture of strain gauges and accelerometer sensors. Let's see robust precision signal conditioning. The most common measurement in the structural monitoring and testing are strain and vibration. Strain measurements are usually made with resistive foil strain gauges arranged in full half or quarter bridge configuration. So this is a picture where noisy raw signal is get from the sensor. After the conditioning, we got the filtered signal. Distributed measurement systems. Continuous monitoring of real-time structural performance data is emerging as a critical strategy in the long-term maintenance of bridges, buildings, stadiums, and other large structures. These applications require robust, intelligent data acquisition systems that can operate reliably in remote, unattended locations without sacrificing the measurement performance or versatility to deliver reliable, accurate sensor data. So this is the example of distributed measurement system. It's shown in the figure. Software technology. What is software technology? Software is a critical component of SHM system. Whether performing a portable test on a structure or deploying a long-term monitoring system, consider our software application needs for inline and offline data analysis, ease of use, and data post-processing and management. It does easy and powerful graphical programming, data analysis, and data management. So here is a software where we have got the signal. And this is how it monitors and concludes. So here are some examples of structural health monitoring. So the first one is of Rio Anterior Bridge, which is located in Greece. It has more than 100 sensors monitoring the structure and the traffic in real time. The second picture is of Huey P. Long Bridge, which is located in USA, and it has more than 800 static and dynamic strain gauges designed to measure axial and bending load effects. And there are many more structures which are using hundreds or thousands of sensors.
So this was all about the damage. Nothing is perfect in this world. Nor are these structural health monitoring technologies. Even there are some factors which affect these technologies. So come, let's see what are the factors that affect these technologies.
Though many damage detection techniques have been successfully applied, many are still a question as some of these techniques aren't sensitive to environmental conditions. The information can't be directly applied to damage detection algorithms. The system should be able to distinguish between changes caused by temperature fluctuation or by the change in boundary conditions. A successful SHM system is only possible when robust techniques are updated so that they can differentiate between environmental, which is moisture or temperature, and operational, which is speed and mass changes. So, as a conclusion, what I could say is SHM is necessary for the present time, and as rebuilding any structure is costly and could be dangerous to living lives. So, it's better to maintain a structure and extend its design life. As people are being aware of SHM, the attempts on identifying damage are happening in global basis from about the last decade. SHM to be accepted in many normal practical operations, the vigorous system should be developed, which is a challenge for engineers, so that the predictions, the information about past, present, and future, the environmental and operational conditions could be almost accurate, and the testing and maintenance work can go hand in hand.
So these are the factors affecting SHM. This is all about structural health monitoring. I hope you all have understood something about structural health monitoring. Thank you for listening me. Thank you.